The third property we're going to talk about is density. When we say density, it's the degree of compactness of a substance. The degree of compactness of a substance. Now, a small stone can sink, but a big ship cannot sink. The reason is because for the stone, the particles are closely packed, very tight. But when you take the ship has a large hollow area over here that is unoccupied, only occupied by air. And that is why a ship will float, but a stone will sink, due to how compact the atoms or the particles are in the substance. Now, when we come to science, we can define density using its formula. Density is equal to mass per unit volume. Mass per unit volume. Now, we know that as we move down the group in alkali metals, as we move down, the masses of the substances increase. Okay, and so do their volumes. And so do their volumes. Now, when you take lithium, the general rule is that as you move down, the density will increase. When you take lithium and sodium, you can see this clearly over here. The density of lithium is almost half of the density of sodium. So sodium's density is almost 2 times that of lithium. Okay. Now the reason is because from lithium to sodium, the mass changes, but the volume does not change that much. From sodium to potassium, the same mass changes, but for potassium, its volume is greater than sodium's volume. Therefore, when you divide the mass by volume, potassium is going to have a smaller density than that of sodium. So this is where the only exception takes place. Sodium has a higher density than potassium because mass per unit volume of sodium is greater than mass per unit volume of potassium. But when you see rubidium and cesium, they all follow that rule. So generally, we can say density increases down the group, but sodium and potassium are an exception.